Viewers, welcome to add-on. In this question, we are asked to find the hexadecimal equivalent of the decimal number 946. And these are the four options which are given to us, right? So let us start with the solution. So the decimal number which is given to us is 946 and we are specifying the radix which is 10, which signifies that the number is in decimal number system, right? And to convert it into hexadecimal number system, the conversion technique is quite simple. We have to divide the number by the radix of the hexadecimal number system, that means 16, which is the radix of the hexadecimal number system. We have to divide 946 with 16, which is the radix of the hexadecimal number system, and then the dividend we are getting, we have to continuously divide it with 16 up to the point we are getting 0, and then we need to keep the track of the remainder. So the summary is, suppose 946 is divided by the radix of the hexadecimal number system, which is 16. So when it is divided by 16, we are getting a quotient, as well we are getting a remainder, and this quotient, or we can say this is the dividend, this is the divisor, we are getting the quotient here, and this is the remainder here. So this quotient will be again divided by 16, and then we are getting a quotient here or a remainder here, and this process continues up to the point we are getting a quotient of 0. Okay, so here let's start with the first step. 946, when it is divided by 16, we will get a quotient of 59 and a remainder of 2. Okay, so 59 is again, as I have said earlier, the quotient should be divided again with radix of hexadecimal number system 16 up to the point we are getting 0 in the quotient place. So here 59, obviously it is not 0, so 59 will be again divided by 16. So we will get a quotient of 3 and a remainder of 11, and then 3 will be again divided by 16, so we will get a quotient of 0 and a remainder of 3. Okay, so now we are getting 0 in the quotient, so this implies our division process will stop here. There will be no further division, and as I have said earlier, we have to keep the track of the reminders, and these are the reminders which is generated in the division process, and we need to keep the track of it in a bottom to top approach. That means in this direction, bottom to top approach, we will write the reminders in bottom to top approach, and that will be our hexadecimal equivalent. So here, the in the bottom we are getting 3, then we are getting 11, but we won't write 11 because in hexadecimal number system we know up to 9 we will write it as 9, then for 10 we will write it as a in hexadecimal number system, then 11 we will write it as b. So here instead of 11 we will write b. Okay, and then we are getting 2. So when we are writing the remainders in a bottom to top approach, we are getting 3b2, and we need to specify that the radix is 16, which means the number is in hexadecimal number system. So this will be our equivalent, or we can say the hexadecimal equivalent of the decimal number 946. Okay, so in this case our correct option will be option number D. Okay, thank you.